Hi, I'm Tommy Mullaney. I'm a program manager on the security team for SQL Server, and I'm really excited today to share with you a little bit about a new feature we have in SQL Server 2016 called row-level security. So what is row-level security and why should you care about it? So here's the scenario. Applications often need to limit a user's access to only certain rows of data in a database, and reasons could be regulatory compliance or simply just adherence to basic security principles. So for example, let's say we have an oil and gas application that needs to restrict access to well production data based on an analyst's region or role. Or for instance, a healthcare application might need to restrict access to patient data based on a doctor's staffing assignments. Or another common case that we've seen is in a multi-tenant application with a shared database, shared schema tenancy model, you need to ensure that tenants cannot access each other's data. So these scenarios have existed for a long time, and customers have come up with a couple of different solutions to implement row-level security. On the one hand, you have SQL views, and on the other hand, you have custom application code. And both of these solutions have problems. So SQL views, on the one hand, are decentralized. You need to create a view on top of every table that you want to protect, which ends up spreading your access logic all over the place. They're also susceptible to runtime errors. And of course, as your application grows, this becomes difficult to maintain, particularly in the context of application upgrades. It ends up being an awful lot of work to keep this all rolling. On the other hand, we have custom application code, which similarly is difficult to maintain as your application grows. It also has the issue where your access logic is separate from your database. And so if you have multiple applications that are all accessing and referencing the same database, you need to re-implement that access logic for each of those different applications to make sure it's always applied. And not only that, but custom application code is actually impossible in some scenarios where you don't own the application code yourself. So for instance, commercial off-the-shelf software has this problem. So to address these problems, we've added in SQL Server 2016 a built-in row-level security feature, and we're really excited about it. What this feature does is it centralizes your data access logic within the database itself. It offers fine-grained access control. And what this means is it gives you the ability to control both read and write access to specific rows of data in your database. And what's nice about it is your access criteria can be extremely flexible. You can use control access to rows based on things like a user's identity, their role or Active Directory group memberships, based on their connection data or the time of day. Really, you name it and you can do it. So the second point about RLS that's really great is application transparency. What this means is that RLS is completely transparent to your application code. You don't need to make any changes in order for the filtering to work. This reduces the complexity of your application code and means it's a lot less work to maintain it as your code base grows. So the third point that RLS offers here is centralized security logic. And what this means is that your data access logic is all centralized within the database itself. And what's great about this is that it helps you maintain a consistent data access policy across all the different applications that need to access this data. And not only that, but it also helps you minimize the risk of accidental data leakage as your code base grows. So how does RLS work? RLS is a form of what's called predicate-based access control. And what this means is it works by automatically applying a security predicate to all queries on a table. And this predicate is what determines which users can access which rows. So to take a really simple example, for instance, your predicate could be as simple as where a sales rep name equals the current user. And more sophisticated predicates could, of course, include joins to other helper tables to look up additional information. It's completely up to you and what your business logic requires. And RLS supports two types of security predicates. On the one hand, we have filter predicates, which will transparently and silently filter the results that are returned to select, update, and delete operations. And we also have, on the other hand, block predicates, which will explicitly block and throw an error on insert, update, and delete operations that don't satisfy the predicate. So for instance, a filter predicate would mean that if I was a doctor and I queried for all patients in a patients table, I might only be returned those patients who are assigned to me. Or a block predicate could be used to, for instance, prevent a tenant from inserting a row that belongs for the wrong tenant. So then how do you implement RLS in your own database? So typically you'll start with some table that has at least one column that contains a label or labels that are used to determine which users can access a particular row. So in this case, let's say we have a customer table and we have a sales rep name column that contains these names of sales representatives that are assigned to each customer or each row in this table. So then if I wanted to enable RLS on this table, the first thing I would do is I would create an inline table valued function that defines my access criteria. And this function is going to be applied to all queries against my table, and that's what's going to determine which users can access which rows. This function typically is going to have at least one parameter that corresponds to a column from my original table. So in this case, I'm going to pass in that sales rep name as an argument. And wherever this function returns at least one cell, the row in my underlying table, my customer table, will be accessible. So in simpler terms, wherever this highlighted predicate here evaluates to true, the row will be visible. So for instance, our logic in this case is where the sales rep name for a particular row matches the current username of the current user executing the query, or if the current user executing the query is named manager, then they will be able to see the row. So now that we've defined our access criteria in this function, what we'll call a predicate function, we need to create a security policy that will actually bind this function as a security predicate to our table. And so we have some new DDL here. It's pretty straightforward. We're going to create a security policy and then add this function as a filter predicate on our customer table. And notice again, we're passing in that sales rep name as a parameter. And we're also going to add the same function, reusing the same logic, as a block predicate on this table. So that way we have full coverage over all read and write operations to make sure that they must conform with this logic that we've defined. So with that, I'd love to dive into a demo and show you how this works in action. So I've gone ahead and created a sample database here, and I'll show you that I am connected as the DBO user. This database here, I've already gone ahead and added in a customer table as part of the sales schema here and filled it with some sample data, very similar to what we had on the slide. So each row here represents a customer, and each customer, of course, has a name, an email address, and a phone number. Also, each customer belongs to a particular territory. So that's a little different. We've done that to make it a little bit more interesting here for the demo. So in addition to this customer table, we also have an employee table as part of the human resources schema. And so in this employee table, I've gone ahead and added a couple of sales representatives. So each employee here has a username, and then they're also assigned to a particular territory. The row level security logic that we'd like to apply here is so that each sales representative can only see customers who belong to their assigned territory. So I've gone ahead and also created a login for each of these sales representatives so that they can connect on their own. So let's say I'm going to pretend to be sales rep 1 right now, and I load up Excel and I want to go load up all of my customers from this database. So I'm going to connect to the database on my local machine here, and the database is Contoso RLS demo, and I just want to get a list of my customers, so I'll just do a simple select star query. Okay, and I will connect using the credentials for that sales rep 1 login that I created. And so now this sales rep 1 can access the customers in the customers table of this database. Problem here, of course, is that I'm sales rep 1, I'm assigned to territory 4, and I can see customers for all the different territories. So this is where we're going to enable RLS to fix the situation. So if we switch back over to SSMS, and again, I'm connected here as our DBO user, let's enable RLS on this customer table. So the first thing we're going to do, and this is not required, but it's the best practice, we're going to create a separate schema for our RLS objects. And this is a way to centralize them and keep them separate and inaccessible by other users in the database. So we're going to do that, create the security schema, and now we get to the real heart of RLS here. So as before, we're going to create this inline table valued function, this predicate function, and we're going to call it our customer access predicate. And this time, rather than passing it a sales rep name as a parameter, we're going to pass it a territory ID corresponding to the territory ID column in the customer table. And now, instead of just using a simple where clause, we're going to actually select from the employee table in the human resources schema. Recall that wherever this function returns at least one cell, the row will be visible. So we're going to go look up in the employee table where the username of the employee matches the current user executing the query, and where the territory ID assigned to that employee matches the territory ID of a particular row. And so what this means in plain English is that sales representatives will only be able to access customers in their assigned territory. Or we also have this catch-all here. If the current user is a member of the DB owner role, then we're going to say you're a database admin and you can see all of the rows. So let's go ahead and create this function. And now to bind this function to our table, we're going to create a security policy that adds this function as both a filter and a block predicate on our customer table, just as before. So now that we've gone ahead and done that, let's test it. So the first thing I'm going to do is do a simple select star from our customers table. And recall that I'm connected right now as the DBO user. So of course I can see all rows because I'm a member of the DB owner role. So now let's impersonate this sales rep 1 just to see what it would look like if they were to do the same thing. So now if I'm impersonating sales rep 1 and I'm going to do the same select star from customer query, and now I only see customers who belong to territory 4 because that's the territory to which I'm assigned. And what's great here is if I try to, for instance, update all customers who are in a territory that I'm not assigned to, the filter predicate will filter out all of those rows so that none are actually affected. Because I don't have access to territory 3, I'm not able to access any rows that belong to territory 3. They're all just silently filtered out. It's as if they don't exist. Same goes for delete. If I try to delete customers where their territory is territory 5 instead of 4, again, 0 rows are affected. And moreover, if I try to insert a new customer for a territory that I am not assigned to, in this case, territory 6, you'll see that the block predicate kicks in and prevents me from inserting this bad row that violates the predicate. So now, if I switch back over to Excel here and pretend to be sales rep 1 again, remember I'm connected as this sales rep 1. If I refresh my query here, now I only see customers who belong to my assigned territory. And so what's nice here is I didn't need to make any changes to the Excel application code. I didn't need to update my query. All of this is done completely transparently to the application. It's all handled for you automatically by the security policy in the database. So with that, that is row-level security for SQL Server 2016. I want to thank you very much for tuning in and listening to this. This is a feature that we are really excited about, and I know customers have been asking for it for a very long time, so we're really excited to bring it to you, and we hope you're just as excited as we are. I'd like to leave you with a couple of resources if you want to get started trying out RLS yourself. I think that's the best way to learn, is to play around with it. We have a number of blog posts that are linked to here, including stuff on our SQL Security Team blog, which contains a whole host of useful examples, tips and tricks, ranging from getting started materials all the way to some fairly advanced stuff. We also, of course, have our official documentation and demo code and samples that you can try out, similar to what you saw today. So I'd encourage you to take a look and give it a try. And as always, please feel free to reach out to us. We're actively working on these features. We're really excited about them. We're excited to bring all of this to SQL Server 2016, and we'd love to hear your feedback. Thanks so much.